Hello, everybody. Tonight we're going to be working on building the rock, paper, scissors game zone app. It's the last exercise for chapter 5. Um, I had thought I had already video recorded this, and if I have, I can't find it. I lost it on YouTube somewhere. Is kind of my joke. Um, but I did record last week kind of the logic of rock, paper, scissors, explaining the process of kind of figuring out the problem in advance. And this really kind of circles us back to how problem solving is really important, like as a first step before you write code, especially when the application gets a little bit more complicated. And if you recall, I had done this isn't the exact file I created. I think I did it in Excel actually, but I had made this kind of like logic table, if you will. um, and here, let's zoom in a little bit here so you can read this. But basically, we figured out with rock, paper, scissors, there's 9 possible outcomes. Um, there's 3 ways to lose, three ways to win, and 3 ways to tie, right? And what we did here is we kind of made a little chart basically of what all the possibilities are for you as a human being choosing rock, paper, scissors manually versus the computer picking it randomly, and then what the result of it is. And then when you look at these possibilities and you start to map it out as a game, and I know this is a little bit small on people's screens probably. Um, so I'm trying to get zoomed in as far as I can while still having the whole thing on the screen. We basically start the game by asking the person to play. You enter your choice numerically. You'll type the numbers 1, 2, or 3. The user will for rock, paper, scissors. The computer will randomly pick one of those. We'll compare them. Um, and if it's a tie, right, so the first decision box here, if it's a tie, we say that and we go back and let them play again if we so wish, right? We don't have to do that part. But otherwise, if it's not a tie, then we start comparing the user's choice to the computer's choice, and then following this whole pathway of basically if else if statements is what these are. And then what outputs would happen. And then when you get all done, you can prompt the user to play again. I'm not really super worried about getting the play again part of it worked, but if you wanted to bring it up to a higher level, you could certainly do that, right? That does require looping, right? But let's get just the straight program logic to work, because if you can do that, then all you have to do is take the whole program and put it inside of a giant loop, and you have a program that keeps playing rock, paper, scissors. It's not very hard to do. All right, so this is kind of the lay of the land, and I may refer to this to kind of figure out how to write my code. I might use different names than I did here, and I forget if this is one that I created or maybe we did in class with a group of students, but it was a while ago. But I have these, scenarios here that I can refer to for sure. Now, the one thing that I think is kind of interesting is we figured out right off the bat, we check for ties first because that crosses off 1/3 of the possibilities. And we do that right at the beginning. So you don't have to run all that other logic, right? It makes no sense to do that. All right. So let's jump over to Eclipse. And gosh, I thought I had it already running, but maybe not. Maybe I closed it. All right, so Eclipse is coming up on the screen right now, and I'm going to start coding inside this environment here. And this is going to be a regular console app the way that we've been building them. You just have to be patient here for it to launch. So it finally launched, and of course on screen number 2 rather than the screen that I'm working on. Hey, but whatever, right? All right, so here it is. I'm going to go ahead and close my previous work. This is technically a separate chapter 5 exercise, like the ones that we did before. So if you look at these files, this is one group of exercises in one assignment. So rather than throw rock, paper, scissors in here, which I could do, right? I could totally do that. I instead am going to opt to create a new Java project, and I'm going to call it chapter 5 rock, paper, scissors, so I know what's inside there. And really, it's a game zone exercise. So if you wanted to say like chapter 5 game zone, that's fine. Rock, paper, scissors is what I'm calling it. let's go ahead and do all the mechanical stuff here. I do need to make a class file. So we're going to make a new Java class. And I guess I'm going to call it rock, paper, scissors. We do want a public static void main, and I'm going to go ahead and click finish. All right. Now that we have the program up here, we are going to be prompting our user for input at some point. So we definitely will do a scanner. So why don't we just add the scanner first? We're going to do that inside the main method here. So let's do scanner. I'm going to wait for it to underline red. We are in Eclipse, so I can do Control Escape to add the library, or you can type it in manually, whatever you prefer, or you can hover and add it. That's a thing too. I'm going to call my scanner input. And of course, we will create a new scanner using system.in to grab content from the keyboard. And so that's all ready to go. I will need a couple of variables. So the user is going to make some choices. So we'll develop an integer for the user. So this will be the user selection. And we also need an integer for the computer. And you could abbreviate it, but I'm just going to call mine computer. That works for me. So 2 integers, 1 for user, 1 for computer. We probably at some point want to maybe keep track of the score. But you know what? I think I'm going to end up, maybe, and see, I'm wrestling with my thoughts here because I'm thinking like, if we're going to get the computer to randomly choose a value, the question is, when do you have the computer do that? So that's kind of an interesting thought. We haven't done a lot with random value generation here at all. So what I'm going to do is I'm just going to write this line here. So we set up an integer for computer. This program basically will start. And when it starts, the first thing that will happen in the background is the computer is going to do its random number choice, right? There's only 3 possible values. And the way that the randomizer inside of Java works is you have to set it up in a very particular way to pick out a number that's already in a range, right? So normally what we do is we put in, we run the random function, and then we tell it like, how many values we want basically. And then it will pick basically in a range from 0 to that number, but we don't want it to start at 0. We want to add 1 to it in order for it to be accurate. So if I wanted the computer, in other words, to pick 3 values, using the regular random number generator, it would pick like 0, 1, 2, right? While I'm going to be prompting the user to enter 1, 2, or 3, because that's how user brains work. So what I'm going to do is whatever the computer is calculating, I'm going to add 1 to it. I'm just going to put that statement in to begin with. So 1 plus whatever the computer generates. All right, so the way that you do this with Java is you first have to put int inside of parentheses. This is going to tell the random number generator, we want you to generate random integers and not something else. Okay. Then right after that, also inside of parentheses, we call upon the math library. So this is part of the standard Java libraries, but you have to call it in. It won't just be there. And that includes a bunch of standard mathematical methods or functions. The one that we want, of course, is the random function that will be followed by parentheses. So that alone right there will generate random integers, this little statement. If I remove the integer thing in front of it, I believe it generates random floating point numbers, not as useful for us here. Now, to declare sort of like the range, here's where I'm going to put in a multiplier. And really what this says is I'm going to take this and multiply it by 3 to basically convert it into a number range that's accurate for us. So now what a random number generator really does in the background is it generates random numbers between, this is kind of interesting, between 0 and 1. And the level of precision of that is based upon how many floating point values whatever. And you can go into the theory on this, but basically, just suffice to say, this is the code you have to type to generate a random integer in Java that would either be 1, 2, or 3. This is this is the formula for it, right? If you're trying to figure this out on your own, you'd probably be there for days trying to figure it out. Now, the other thing that I'm thinking about in terms of variables is I'm going to have my code basically, so we're going to get messages that will be generated by the code, and rather than kind of manually output each print statement every time an if statement is developed, I'm going to instead set up some string variables that will capture a message, whether it's like win, lose, tie, rock, paper, scissors, whatever, and store it in a string variable. And then at the end, I'll just output the string variable to give the user the correct message. That will make my if statements a whole lot cleaner as I go. My thinking is that I need a few of these. So one will be, so these will all be strings. So for example, I'm going to have one called message, MSG for short, that will store stuff like tie, for example, right? Or lose, right? I'll have another one for the user's pick. Like, what did the user pick? Now, instead of a number, we're going to have that converted into a string. So if the user is going to type 1, and we're going to convert that into the word rock, and this variable will hold that. We'll do the same thing with the computer choice. So we're going to call it computer, not computer, but computer. There we go. Pick. And then we'll also set that to a blank string. So once again, that'll do the same thing. It'll hold the value to convert it to a word so we can put it on the screen. All right. So the program starts, variables are declared. Computer's already made its choice. We don't know that, right? But the computer's already made its choice. Next, we're going to prompt the user for input. So here, I'm just going to do a system.out.print, and I'm going to prompt for one of these. I'm going to say, well, actually, before we do that, let's actually put a message up on the screen. This might be just a politeness. How about like, let's play rock, paper, scissors. Just a message on the screen for the user. Right now, we'll prompt. Okay, and maybe we should put a blank line in between here. So I'm going to do a \n at the end of this statement just to give us a fresh line to work from. Now we'll do another system out. So here's system.out. That's not what I wanted to do. Get one wrong key and it all goes haywire, right? So we'll do a system.out.print, not print line, but print. And the prompt will say, type one of the following numbers. And right, so I'm thinking about how this is going to look on the screen. I'm going to go to a new line here. So even though it's going to be one system out print line, I'm going to output the next piece on the next line. So the first one will say 1 for rock. And you know what? Not that I'm running out of space here. I think I can probably fit it all in on one line. But if you guys are running out of like horizontal space, don't forget that you can always concatenate inside of here, move down to the next line and keep typing like down here, and I'll just do that just for the sake of it. And then I'll do another new line, and then I'll say 2 for paper, right? And then another new line and 3 for scissors. There's our prompt for the user. And you know what? now I'm thinking, I was just going to say uh, print, and I'm just thinking of where the cursor is going to end up. The cursor will end up flashing at the end of scissors, and I'm not sure I want that. So I'll do a print line. Um, and we can always clean this up later if you don't like it. Okay, now we want to grab that input and we want to store it in the user integer variable. So we're just going to say user equals input dot next, like so. And actually, I'm sorry, should say read next int. Type that way too fast. All right, so that's captured it. So now we have the user's choice and the computer's choice. We have all the info we need to make our choices. Now, the task that we have that's more challenging is we've prompted the user, they've entered their choice, computer has already made their choice. So we kind of flip the order of these, but whatever. And now we're going to output, it says output equals user chose my choice and the computer chose whatever. All right. All right, but here's the thing that we maybe didn't think about here, and this is maybe bad algorithm design, is okay, what if you have a snarky user, right? And some users are that way. They try to break things instead of play along, and they enter an invalid value, right? That's a consideration here. So let's put in a little snippet of code here to make sure that they entered a value that's okay, right? So if not, what's going to happen is I'm going to prompt them again. So I'm going to say if the user's choice is less than 1, so they type with 0 or a negative number, or two pipe symbols, that's the shift with the backslash key, the user choice is greater than 3, right? So they type 0 or 4, doesn't really work. Then we're going to say to them, message, and you know what? I have this pre-typed, so I'm just going to copy paste it in. So here it is. I'm just going to basically say invalid selection, must choose a number between 1, 2, and 3, and I'm asking them to enter it again, right? Now, if, for whatever reason, they don't enter anything, okay, so let's say if we're assuming that at this point they would put in the correct thing, right? What if they don't do it again? Do you keep? Yeah, we could set this up as a loop. We could. I really don't want to go that route right now, but we should have something in here that kind of says, "Hey, man, type in the right thing." We'll give them basically one chance. Right. All right. Now we need to do the following steps, which is to break down these selections here and start testing them one at a time. And the first part of it is, so I just want you to follow along with me here on this process. So here goes the first part of it. So let's just say now we got the right input. Now I can check if the computer equals 1, then I'm going to add to my if statement. And this is, I want you to keep in mind here, what I'm doing is I'm building strings is what I'm doing. We're going to say if the computer selection is 1, then we're going to store this string, rock. Why? Just for output, by the way. Else, if the computer picks 2, we'll say computer pick equals paper. Now I'm going to just do a pause here for a second and have you think about what I'm doing. I'm not doing the game logic yet, right? And a lot of people might be perplexed by this. You're just, hold on a second. You're just getting the words stored in the right string. Yeah, that's all I'm doing, right? Okay. Is that shown on my chart here? No, it's not. This is kind of a hack that I'm adding after the fact. I wouldn't technically need to do the part I'm doing right now. I'm just putting it out there. But for me, this is kind of a nice way to build a message without having to rely on hard coding it each time. So once again, just to kind of give that explanation. So, all right, so else the computer picks two, it's paper, and then of course, I mean, you can start really going down the rabbit hole here. And normally, I should mention this in Java, we normally would do it like this. I don't say else if. Really, it's not really an indent per se. Now, the reason I kind of break it down like this is for me, and maybe your brain thinks the same way, really an else if is kind of doing this, So we're just going through all the scenarios here. The other thing I'll have you guys notice is as I'm typing this in is, do you notice that I am not putting curly brackets around my if statement code, whether it's true or false? And you guys are like, well, Ty, I thought you said you should always put those curly brackets in. And you know what? Generally, the answer to that is yes, right? But because there's only one statement inside of here, okay, I can kind of do that. Okay, another thing that I could do too, and I'm just kind of giving you guys a bunch of different possibilities here, is could I do this more efficiently with a switch case statement? I think so. And so here's what I'm going to do. I'm going to write it. So I wrote it like this. So I do that with the computer, right? And right, so this is so I'm writing this for the computer, but I also need to write one for the user, right? So the user, so I could take basically all this code and also write it for the user. All right, so let's leave that in place, and I'm going to write this as a switch case statement instead to show you kind of the different approach, right? So you can do a switch. What are we switching on? In this case, we're going to switch on the integer the computer chose. We're going to switch on computer. Then inside here, we're going to say case 1. And then basically what's going to happen here is, and now if you think about this, right, and is we're going to basically do the same thing that we would do in the if statement, we just use a switch mechanism instead. And this might be a more cleaner logic for you. And this is also my opportunity to kind of teach you this particular skill. So here's what I'm going to do without going like into the textbook and stuff. I'm just going to very quickly do Java switch case. Sure, let's find an example just so you can see it. And of course, where do I end up? W3 schools. But basically the way that they do this is they have an expression that they're checking. So in here would be whatever variable or value we're checking. And then we set up each one of the situations, and then it'll have a break statement and whatever code you want in there. The code's going to be really, really simple, by the way. So very, very simple setup, works great with integers, by the way. So I do need to put this inside of parentheses, right? The other syntactic thing is you just say the case, and if it's just an integer or a variable name, there's just a colon that follows, and then you indent your code block. So here, so the case of the computer being 1, I would just basically use this statement, right? And then I would break, meaning I stop executing the code at that point. Then if I have another case, the case of 2, we would say computer pick equals paper. And I don't know if you guys are seeing like how this is maybe a little bit cleaner, right? I think it's easier to read. I really prefer doing it this way a lot when you have a lot of different situations, and that way you don't have to write this if statement that never ends. So I'm going to kind of stick with this approach here. So I can just copy this one, and I see I type user pick here, and that was even incorrect. I should say computer pick equals scissors, and then a break. Now, another thing that's common in switch statements is this default statement. I'm going to show you how this can actually be useful, because maybe when you read about it, you're like, well, why would you ever use that? Well, if somebody picks the wrong thing and it's not 1, 2, or 3, I can handle it right here. I can put a message up on the screen that would appear if one of those 3 scenarios is not correct. It's something like, invalid selection, choose again, for example. But I'm not going to give them a chance to choose again at this point, but I could engineer that in later. But I'm just going to do just a really simple system out print line here. And I'm going to say system.out.print line, and then say something like, you entered an invalid entry. Now, here's the thing, and I want you to think about this. I'm doing this on the computer. The computer is not going to pick the wrong one. It's the random number generator is forcing it to be 1, 2, or 3. So this scenario is never going to hit, if you guys are catching my drift. On the user end, though, it would. So you do not have to include a default, right? But it's a good idea if you have a scenario that wouldn't be covered by your inputs. All right, so this allows me to replace this block of code. Is it less code? No, not really, but I think it's easier to read, so take it for what it's worth. Let's do the same exact thing with the user. And yeah, since the code is basically identical, we're just going to fit different variables in here. So I'm going to just take computer pick. Well, we're checking user, but the variable name is user pick. Okay, I just wanted to verify that. So we're just going to replace that with user, and then here I am going to have a default. And I am going to do a system out print line and say, you're an idiot. No, I'm not going to say that. I'm going to say that is an invalid choice. And then I could also say, I could put a message in here and say, the user pick could say invalid choice. And maybe even like error, I could maybe say error or whatever. Up to you what the message is. But some indicator that they're not being very clever or listening to direction. Now, if you notice, when they do the default, you notice how these other ones have a break statement, because when a certain case hits, the break statement pops you out so you don't process the rest of the switch. The default doesn't, though. Why? Because it's at the end. It doesn't need one. It'll pop out either way. So that's why I don't add a break statement here. All right. So this is my switch statement for users, switch statement for the computer. That allows me to eliminate that other code, which I already removed. I still have this check built in. I mean, I could say that I really don't really need this here, like I said before. All right. So next thing we need to do is, now that we have the conversions, basically, that it's changing the numbers to words. That's really all this code is doing. It's taking the numbers, converting them to words. Now we're ready to do the game logic, right? And this is where we will have some pretty complicated if statements. There's kind of like really no other way to do it, folks, right? So let's take a look at how to do that. So here, I'm going to come out of the switch statement. I'm still in the main method here. All of this is in the main method. So the first thing that we're going to do is now we check to see if there's, right? So the first scenario is if the user's choice equals 1, And then I could also do, and this is kind of a weird thing to do. I could say if the computer's choice is one, and if the user's choice is one and the computer's choice is one, I can just generate a message saying tie, right? But here's the logic I'm going to follow, and this might not match up with what you're doing, by the way. So some people will write it as a compound statement. I'm going to write it a slightly different way. So follow with me here. So if the computer is also choosing one, so the user picked one, the computer's picking one. Yes, this is a nested if statement. Then I'm just going to have a message basically saying, all right, well, in this case, the result is a tie. Right. Else, okay, if it's not, they don't both choose one, maybe the user chose one, and maybe if the computer chose two, the message would be what? So here's where you have to think about your game logic. And if you're not sure, that's why we did this goofy thing right here. It's like, oh, the user chose one, which is rock, and the computer, okay, that's tied. Well, now they're choosing paper. Two is paper, right? That will be a loss. So if you don't remember, you can look at the chart, but I'm hoping you would know that, right? Loss. All right. So if you guys are kind of feeling where I'm going with this, um, yeah, loss. I'm just looking at my logic from before, and I'm like, I'm not sure. All right, so we'll see how this comes out in at the end here. So now, if they didn't, and I want you to think about this, if they didn't choose one and the computer didn't choose two, the other scenario is it chose three, and then what happens in that scenario? Well, okay, this doesn't really help us, does it? I want you to think about the logic of this. And so I can't say tie, loss, or win. Who's winning or losing? Okay, this is the scenario. If you choose rock and the computer chooses paper, who's the winner? Yeah, you guys didn't follow that, did you? All right. The reality is the computer is the winner. So the message really isn't win, lose, or tie. The message is a tie if it happens to be the same, right? You know, who won this one? It's a tie. Otherwise, what we're asking is who the winner is. The winner in this scenario is the computer, right? And then in the following scenario, it would be you, right? All right, you guys will see this, you know, as I'm kind of going here. And what I'm going to do to kind of give you a little bit of clarity is here's the output message that I'm going to use ultimately. So I'm just put this at the bottom here, and then you'll see a little more logic in what I'm doing. So in other words, the message that'll come up on the screen at the end of all of it will say you picked, and it'll say rock, right? That's the user pick that we were generating, and the computer picked paper. The winner is it'll be computer or you or tie, right? So there you go. You could engineer this very, very differently, by the way, and I'm not going to tell you that it's wrong. I've seen like many, 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 many solutions on this. This is just one that I've used a few times, and it works kind of nicely. So, all right. So here we'll go user equals two. So okay, so if the user didn't choose one, they might have chose two, right? All right, so here's the scenario if the user chose two, and then also if the computer also chose two. All right, so in that situation, once again, the message is a tie. So I'm just gonna paste that in right here. The message is a tie. There's an else to this, and the else would be and I'm going to go down here. I'm going to keep following this format. The computer chooses 3. What's the scenario there? Well, the message would be that the computer wins, right? Because scissors and paper, scissors cuts paper. 2 is paper, 3 is scissors. So here we'll say the winner is the computer. And if it's not the computer, then it must be you. And really, maybe I shouldn't have called this message. I should have called it winner, the variable. Well, next time. So I'm going to do that. And I could refactor it or whatever, but I'm not going to do that. All right, so this handles all the possibilities if the user selects 1. This handles all the possibilities if the user selects 2. If they don't select 2, then the only other possibility is that the user selected 3, and I don't have to say else if on that one. It's just a given that they selected 3, but I also have to check, did the computer pick 3? So I'll say if the computer picked 3, then the message, once again, both of us pick 3, will be tie. And then the else on this, I mean, at this point, you're probably seeing like the pattern of the logic, or, hopefully. If not, you could write it a different way until it does make sense to you. And I really meant to say if here. So if the computer is 1, then the message will be the computer 1 in this scenario. Otherwise, the only last possibility is, and notice we're not checking anything here because it's the last possibility, is that you won. Like so. All right, so that's all the game logic right there, believe it or not. And you know what? I didn't even have to spread it out so far. I could have used some combination statements, absolutely, and a lot of people write it that way, but this will work, what you see on the screen here. And then really all that's left to do is to output the results. All right, so I'm going to run this, and I'm noticing, okay, so I'm not liking how this second switch statement looks. So I'm going to tab that in. It's just a little cleaner looking to me. Let's try running this and see what happens. All right, here's the save. Here's the run. All right, so we're got the console at the bottom there. Let's take a look. Let's play rock, paper, scissors. Type one of the following numbers. I'm going to click in here. And now that I look at it, I probably should have had a little thing, enter your choice, right? Next time, right? So I'm going to type, how about let's type in the wrong value to start with, 4. All right, invalid selection, must choose a number between 1 and 3, 0. Yeah, I'm trying to break it. That's an invalid choice. You picked error, invalid choice. Computer picked paper, winner you. Okay, that is not good, right? All right, so I don't, right now the error checking is bad. All right, not a good setup. So that needs some tweaking. So I would propose that if this is really the scenario, we're better off putting it in a loop. So here's what I'm going to do for right now is I'm just going to make a note to myself, and I'm going to say, put this logic in a loop. Okay. So we'll come back to doing that. All right. Let's run it again, but this time let's try to behave, right? And do what it asks. I'm going to type 1. You picked rock, computer picked rock. It's a tie. Okay, let's run it again. Try 2 this time. Okay, now they're both picking the same thing. Is that good? Or is that just one of the possibilities, right? I'm not really sure. Now, if I type 3 and they both pick 3, I think I got an error in my logic. Can you guys feel where I'm going with this? Yeah, totally. All right, one more time. I'm kind of thinking, where's my, it's doing that every single time. All right, so now we got to figure out why. All right, So this part we're not worried about right now. The computer is picking a random number. Maybe what would be good here is to see what random number that is. Is it truly random? Okay, I'm going to assume yes. All right. Um, the user makes a choice. So if the computer pick, the user pick, user equals 1, user equals 2. Aha. Okay, so I think I found the flaw in my logic. So I have my variables are wrong here in the if statements. So let's be really careful with this. So I'm going to go back once again and re-engineer all this. And now I'm going to apologize, not re-engineer, but just make sure that I have all this coding correctly. And I'm looking at my solution here to see where I went wrong on this. So if the user equals 1, computer equals 1, it's a tie. Else, if the computer chooses 2, computer wins. Else, you win. Then we go to an else. Yeah, and what I'm doing right now is I'm doing a side-by-side comparison with my code on my other screen and looking like where did my logic break and how is it that all of that it's a tie every time, it's not a lot of fun, by the way. All right, so yeah, and I'm not seeing it offhand. All right, so let's see if there's a reason up here this is happening. Okay, so here's the test I want to do is let's just do a really quick system out print line here, like before anything else happens, to see what value is being generated by the computer. And we're just going to output computer. All right, so I'm just going to run this, and right above where it says let's play rock paper scissors, it already told me what the computer picked, so I'm going to pick something other than the computer. Okay, so you guys see what's happening here, right? Maybe it did actually randomly 4 times in a row pick the same value, because it certainly worked just now, right? You picked paper, computer picked rock. The winner is me. Correct. Paper covers rock, right? All right, let's try it again. So the computer this time chose paper, so I'll choose scissors. Yeah, this is a great way to win every time, right? But you know what? I think we're showing that it is actually randomly picking it. It was just an anomaly that I got it 4 times in a row before. So that's really pretty weird. All right. So I don't really need that line. So what I'm going to put here is temp to test random number, and it actually, I'm going to say it worked, right? So just so I know. But if I wasn't sure that it was working, I could uncomment that. All right, now let's do the higher level thing where maybe now we can make a decision on whether or not this is going to loop and where it's going to loop. Okay, so I'm going to kind of do 2 facets here, because going back to my original programming logic, there's probably some steps here I could remove. So the first thing I want to do is what part of the program needs to loop. And well, I'm going to say that I think everything from line 15 down to wherever this is here should all loop. So all of that should go inside of a loop, right? However, okay, so here's the however. How do we get the loop to run the first time? Right, so these are questions that you ask, and I can set up a while loop or I can set up a do while loop, correct? But I'm trying to keep this in perspective here as well, because I want you guys to notice that, you know, the way that the flow of our chapters is, right? Um, we're doing decisions right now. Where do loops come into play? Next chapter, right? We haven't gotten there yet. So here I am trying to put in a looping technique when you guys aren't quite ready for it. But I can give you the general lay of the land, though, of how this is going to operate. Um, we can write code that would basically take this logic and, in other words, ask the question, okay, if the user's not entering the right choice, loop and ask them to do it again. Right? And this is this capability of being able to repeat code and keep a program running is very important. So this is where we're moving next after this particular unit. You can see why it would be very helpful for this game. The other thing would be is if any of the solutions were a tie, we also could set up a loop, or we just, you know, think about how you play rock, paper, scissors, right? You know, you 1, 2, 3, you put your, you know, fist, paper, scissors, symbol, whatever, and then you know, you get a winner, and then you play again, right? Okay, best 2 out of 3, 3 out of 5, 7 out of 9, or whatever. You know, you just keep kind of going like that, and you can build all that logic in here. But you know what? We haven't learned the tools for that yet, so it's kind of a teaser at this point. But the logic that detects whether a choice is invalid is something we can put in a loop. The ability to play the whole game again is something we can put in a loop. And that's really where we move to next. So we don't have that built into our program. So I'm actually going to call this done. This is it. This is the program for right now. I would maybe say that this could all be left out at this point. So I am going to comment it out. So you don't have to include this part. But it's, as you get more advanced programming skills, you start to think this way, right? It's like, oh, what happens if they type in the wrong thing? You know, that whole process. So you basically have to handle those errors by the user. All right, folks, that will wrap this exercise. And if you have different solutions and you'd like to share them with me, just please reach out and let me know. Normally, when we are doing a live class and I have people that have already completed the exercise, we usually see a bunch of different solutions for this, and they all can work. And then we look at which ones are more efficient, right? And we don't have that comparison here tonight, but this video ends here, and hopefully this was helpful for you.